Welcome to our channel Quaint Cosmos. Today we are going to discuss a crucial topic in the field of electronics and telecommunication. The topic is 6G technology actually. And you know that in case of 6G technology, though at present 5G technology is being used, but in near future, we are going to use 6G technology. Okay. So in case of 6G technology, high frequency waves are used. Means will be used actually. High frequency waves in the range of terahertz. Means actually the range varies between 100 gigahertz and 10 terahertz. Right? So this is the range. That means bandwidth is incredible. And due to this incredible bandwidth, ultra fast data rates can be used by using this technology. But there is a problem with this technology, and scientists are trying to solve such problems. The problem is loss of data over long distance. Means over distance, data loss is there. For all the frequencies, loss is there, but for higher frequencies, this loss is much. So we are going to explore in this video the science of data loss over distances. The science of data loss over distance. So I have already mentioned that if frequencies are lower, such as used in case of 4G or in case of 5G, in those cases lower frequencies are used. So accordingly, the law of inverse square law, you know inverse square law, according to that law, if frequencies are lower, then corresponding signal power, loss in signal power will be somewhat less. But if frequencies are higher, such as in case of 6G technologies, I have already mentioned that the frequency range will vary from 100 gigahertz to 10 terahertz. So in such frequencies, that means it varies from microwave to infrared region in the electromagnetic spectrum. Okay, so in this frequency range, over long distances, data loss will be much according to the inverse square law. Okay, so this is a problem to use 6G technology. Next problem is what? Next problem is absorption by the atmospheric air molecules, such as water vapor and oxygen. Water vapor and oxygen in the atmospheric air, they can easily absorb higher frequency waves. Okay, so since they can absorb higher frequency waves, so for the purpose of transmission, means to use 6G technology, transmission of signal is required at terahertz frequencies. But atmospheric air molecules such as water vapor and oxygen can easily absorb those terahertz frequencies, terahertz waves. So that is one kind of problem. So that is a problem due to absorption. Next problem is reflection and diffraction. This terahertz frequency range means higher frequency range waves. Okay, they can easily reflect instead of penetrating through the walls or buildings or human bodies. They easily reflect and diffract. Means actually what happens in case of lower frequencies, they can easily bend around obstacles. But in case of higher frequency waves cannot easily bend around obstacles. Okay, so direct line of sight is required for the transmission of higher frequency waves. Direct line of sight is required. So whenever in the transmission process, whenever higher frequency waves encounter buildings, walls or human bodies or any obstacle, any solid material, either they reflect or they scatter. They are scattered easily. But if they could penetrate those solid objects or obstacles, in that case, I should not use the term obstacle here, because if they allow the high frequency waves, then in that case it is not an obstacle. Okay. Anyway, whenever they encounter, means high frequency waves, when they encounter solid objects, they actually reflect, either they reflect or scatter. So this is one kind of problem. So many problems are there. And the problem increases if transmission distance increases. Okay. So these are the problems associated with associated with 6G technology, where higher frequency waves will be used in future. These are the problems. Yes, potential solutions are there. Scientists are trying to achieve potential solutions, though some solutions are already existing and some solutions require the innovations. So scientists are working on those things. Okay, one potential solution is beamforming technology. Means focusing the signal in a particular direction according to the requirement. Already this beamforming technology is used in case of 5G, but betterment is required to use in case of 6G. So I was talking about what? Beamforming technology. Then smart surfaces or intelligent surfaces are required so that they can easily reflect and amplify the signal. Then one more solution is that placing intermediate nodes so that the signals could be retransmitted or rebroadcasted. Okay, signals. So for that purpose, intermediate nodes are required. Then proper materials are required so that the signals can be transmitted to long distance without much disturbance. For that purpose, new materials are required. So scientists are working on each and every aspect of this technology. Means to solve such problems associated with 6G technology. Means actually problems are associated with higher frequencies. Okay. And what is the requirement of this 6G technology? 5G technology is already in use. You know, holographic communication. So for the purpose of holographic communication, okay, 6G technology is required. For the purpose of virtual reality, 6G technology is required. For high-speed imaging, 6G technology is required. That's why scientists are putting their effort in this area of research. Okay, so much. Everything will be much better if we can use 6G technology, and scientists are expecting within just few years we will be able to use such technology, that is 6G technology. Anyway, so there is much use of this technology, but problems are there, and the most important problem was the loss of power or the loss of signal strength over distances. That means according to this problem, 6G technology can be used easily for short distances. In that case, there will be no such problems, but for long distances, there will be problem. Okay. So, problem is there, solution strategies are there, and if everything scientists can arrange easily, then we will be able to use such technology in near future. Anyway, so this was all about today's topic, the science behind signal loss. Means degradation of signal over distance. This was the topic of discussion in today's lecture. Okay, so this is the end of this video. Thank you for watching this video.